So we're just kind of actually finishing things off with doing some what we call special trinomials. So they have uniqueness to them that once you start to learn them, it actually makes your life a lot simpler. Now the first thing we're going to talk about is difference of squares. Okay? Now I just want to show you something. Let's just do an example, and I want you to kind of do that at the top of your page there, because this sums it all up. If you had x plus 3 times x minus 3, okay, so let's FOIL it out. If we FOILed it out, that would be x squared minus 3x plus 3x minus 9. Now, anything I can do to simplify this? Right, nullify, awesome word. X squared minus 9. Now that's not like the usual trinomials we've been doing. Now my question to you would be, you already know the question, but if I gave you this as the question, and I said, could you factor it? How would you do it? You guys shut the door behind you there, please. How could you factor that? Square root the negative 9. Okay, and then but that just gives me 3. Like, what would it do with that? You're on the right track. But if I just gave you this question, I said, you guys, like, doesn't that look a lot different than the one we've been doing? But it kind of isn't. Because if you put it like this, now we can do it. It'd be what plus what equals 0 and what times what equals negative 9. What would those numbers be? 3 and negative 3. Right? So that would be x plus 3, x minus 3. Now, would there be a quicker way to go from there to there and not have to do all that other stuff? When and only when will you get a 0 x? When they're both the same numbers, but opposite sign. Okay? So 3 times 3, 6 times 6, 7 times 7, those are called perfect squares. So what we're going to be getting to today, when you have x squared minus y squared, we will learn that that is the same thing as x minus y times x plus y. That is the difference of squares. Do you see that where the title comes from? Difference of two perfect squares. If they're both perfect squares, you can just write it. And these are actually called, and you'll learn this more later, these are called conjugates, because they are identical except for the sign in between. And when you have conjugates, the middle term always disappears, because you'll get a minus something x plus something x, so they'll always cancel. And that's why the middle term is missing. So the simplicity of them makes them confusing. Because if I had x squared plus 12x plus 82, you guys could go, well, what is that? Multiplied, yeah. Okay, you know the steps. These, You're like, what? I can't use the same steps. Well, you can, but you don't need to, okay? If you had to do one of these on a test, I'd say, yeah, do it the long way. But if you have to do 50 of them, I'd say, well, why don't we use and you'll see how this will come in handy. So first of all, to be difference of squares, you must be a binomial. It must involve subtraction. And both terms must be perfect squares. And this is like the big, you may need to factor out a GCF before you begin. So it's got to be perfect square minus perfect square. Okay. If it does not follow that, you can't do it. You can't do it this way anyway, because it's the only way you would get the middle to cancel. Okay? So if you look at this one, k squared minus 64. So what you do is you go draw your two sets of brackets. You put a plus and a minus. You know why I know to put a plus or minus? Because the middle term canceled. So I guarantee they're conjugates. And then you do your first ones. All you have to do is separate this into here, and this into here, and you're done. So what times what equals k squared? So you put your k's here, because remember when you do your first, they're going to multiply. And then the outer and inner are going to cancel, and then the last. So what times what equals 64? 8. That's all you have to do. It's a simple concept once you've learned it, but if you've never seen it before, it's actually quite confusing because the middle term's gone. Okay? The next one. What can we do there? Factor out of 2. Very good. Leaving you with k squared minus 9. Ding, 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 ding. Little light should go off. Are those both perfect squares? Okay, actually I want to back the truck up here, all the way up top. Let's list perfect squares. Let's go. The first one. 1, 4, 9, 16, 25, 36. Okay, now let's talk about x squared is a perfect square. What's the next one? X to the power 4. The next one? X to the power of 6. Good. Because that's x to the 3 times x to the 3. And when we multiply, we add exponents, right? A lot of people would say the next one would be x to the 9. It's not. X to the 9 never works, actually. X to the 8. X to the 10. Okay? Good to know. Because x to the 10 is x to the 5 times x to the 5. So I can split this up into k plus 3k minus 3. Does that make sense? Okay. So let's do a little bit. Okay, are these both perfect squares? Yeah, so you just go like this. As soon as you see that, it's like easy, boom. Okay, now, first term. What times what equals 9m squared? So 3m, 3m. And then plus 4 minus 4. Next one. Is this a difference of squares? If this was one whole unit, like one thing, is it not a perfect square? because it's squared. It must be perfect square. So let's see. How is that any different than the one before it? So it's going to look a little bit different, but if we did the red, wouldn't this be, and let's do it in brackets, x minus 2, x minus 2. Is x minus 2 times x minus 2, x minus 2 squared? Okay. And the second set would be y minus 6, y minus 6. Now you can do a little math in these, because this is the same thing as x minus 2 plus y minus 6, which would be x plus y minus 8. I'm just working down. I got the negative 2 and the negative 6 together. The other one, I would have x minus 2 minus y plus 6, right? The negative comes in. That's why you always want to substitute with brackets. And that would go down to x minus y plus 4. Because a negative times a negative. Remember, you have to multiply that negative in, making it a positive 6. Okay, how about next example? Take out the 3. You can do better than that. 3a. Leave me with a squared minus 4b squared. Is this the difference of squares? Is it? Is there two identical numbers that can, or two identical things that can make a squared? Yeah. How about 4b squared? What? 2b. Okay, so we have it, right? So that would be 3a, a plus 2b, a minus 2b. Okay, the next one. What times what equals 81? Okay, so we got the 9 plus 9 minus. What times what equals a to the 4? A to the 2, a to the 2. Easy? It's wrong. I can go further with this one even. Oh yeah. That's how we... Okay. Can I do it when there's a plus? Difference of squares. And I'm going to show you why that doesn't work. But if you go, well, let's try this one. This is 3 minus a and 3 plus a, right? Well, what would you take 9 plus a squared? Say you were going to do that. What would be your guess it would turn out to be? What do you think's the answer to that one if you factor it? 3 plus a times 3 plus a. Okay, let me FOIL it. That's 9 plus 3a plus 3a plus a squared. 9 plus 6a plus a squared. That doesn't equal that. Okay, that's good to see though. Because people want to do 9 plus a squared, but you can't. So I'm glad you asked. How about this one? You guys can do this one now. Is this the difference of squares? Can something times something equal x plus 5 squared? X plus 5 times x plus 5, right? So what you can just make this x plus 5 plus 4, x plus 5 minus 4. Okay, can we do any work in there? 5 plus 4. So this would be x plus 9. This would be x plus 1. Because when you take 5 and negative 4, you get 1. So here's the steps. If you can factor out, take 1 out. Now this is only when it is the difference of two squares. Put a minus in one bracket, a plus in the other. With you guys, we did a plus minus. Doesn't matter. Minus plus, same thing. The root of the first goes in the start, and the root of the second goes in the end of each bracket. Okay, there's just one more I want to do with you. Okay, this is one of those questions that if you're a teacher, you love it. If you're a student, you're like going, oh man, plus 72x. Okay, that's kind of a beast of a question. This is a high level question, probably a 10 out of 10. Very few students would get this if I didn't show you how to do it. Okay? In fact, does anyone throw at anything? What do you want to do next? Take out. Okay, so we'll see if this class, if we can do this question. I'm not going to help you at all. You tell me what to do. So we want to take out 2x?
No, you can't. Oh, yeah, sorry.
Okay, 2x. What would I be left with inside? Negative. Plus 36. Okay. Any suggestions on where to go from here? Yeah. Except I wouldn't, because you want them in order of degree. Okay, so let's do the plus times thing. What would the signs be? Negative, negative. Nine and 4, negative 9. Now this is a type 1, isn't it? Because there's no number. I know it's an x to the 4, but what would I write? What should I write? This is a type 1. Good. FOIL it out. You'll get x to the 4, and then you'll get minus 4x squared minus 9x squared, which equals negative 13x squared. Yeah? Difference of squares. That whole unit that we did about 30 seconds ago. Remember that? Where if you have two perfect squares with a subtraction sign, you can do that? This became that, this became that. when there's a difference of squares. Honestly, the name, I get that question more, like, what's the difference of squares? Even in the last class, someone said, hey, that's like taking the difference of two squares. I said, yes, it is. It is, right? So when they're both perfect squares with a minus sign. See? Both perfect squares with a minus sign. Both perfect squares with a minus sign. If you look up here, both perfect squares with a minus sign. Both perfect squares with a minus sign. That's what the difference is, minus. Okay? So this is a really good question to even have on a study sheet. The harder example you could put in a study sheet, the better you learn. The easy ones don't really help us that much, unless you're really learning right from the basics. Okay, so here's your assignment. That's as far as you can go, yeah. If you put this in your calculator to y1 and this into y2, you would get the same graph.